Hello and welcome to the next video in the series Statistics for Everyone. Today we'll be talking about why errors are important. So let's say you see a bar graph in the paper. Maybe it's about the length of Dutch men and women over about 30 years. With the graph there is a statement that says Dutch men are taller than Dutch women. Something really important is missing from this graph: error bars. You may have seen these lines in newspapers without actually understanding what they meant. What are error bars for? And are they important? To understand this, we first need to understand what a sample is. If we want to know the average height of Dutch men and women, we could measure everyone in the Netherlands and take the average out of it. This would take a lot of time though, and is not necessary. Instead, we can select some Dutch people at random and take their heights, and we will get an average height that is approximately the true average height. This is called taking a sample, a common way of doing statistics. Now, what does taking a sample tell us about errors? For that, I will not study the average length of all Dutch people, but now I just want to know the average length of 20 people. 10 women and 10 men, all of random height. To make it more clear, we can sort these men and women by height. From the 10 women, we can sample 2 women at random to calculate the average height. Now remember, it may seem weird to just sample 2 women, because we can just measure all 10, but in the true situation these 10 were the entirety of the Netherlands. Now for men, we will measure all 10 individuals and calculate the average height, but this is just for explanation's sake. So, for women we have sampled these 2 individuals at random. They have lengths of this and this high, from which we can calculate the average height. Now, we select 2 new women at random. Remember, this was the graph of our first sample. If we now calculate the average height, it's this high. That is quite a difference. We'll calculate the average height one more time. Now we can actually see that it almost seems like women are taller than men. The sample doesn't seem to be very reliable because it changes all the time and we don't get a good approximation of the real average height of these 10 women. This is shown by the error bars. Because there is a high uncertainty, the error bars are quite wide. Let's now try the same thing, but this time not with a sample of 2 women, but a sample of 8 women. We can plot the average height again and then take a new sample. Do you see the difference in average? It's really small, right there. We can now look at the error bars again for a sample of 8 women. It is way more narrow because there is a higher certainty that the average that we measured is actually the average of the 10 women. Yay! Now back to the average height of all Dutch people. We look at the bar graph from the paper again that was missing error bars. Now you may understand why it is so important to know the uncertainty of a graph. Yes, it is possible that the uncertainty is very low and Dutch men are actually larger than Dutch women, but it is also possible that there is a huge uncertainty and women may actually be taller than men. So, next time you see a graph that, like this one, doesn't have any error bars, think twice. Errors should always be shown in a graph. Thank you so much for watching. Did you like what you saw? Give it a thumbs up. Bye!